world in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Sheesh, I'm early. What's up, Star Prod? Ugh, what's is Alastar, the radio host? I feel like we got to get you a voice box thing or something that makes you sound like that. Be cool. Yes, Star Prod, I did get your DM. I'll get to it tonight. I'll get you your reward. I feel better today, but still sick. All good. All right, let's start this shindig up. What is that? And I got a shout out from Zach. What's up, Zach? Is Zach here? I missed the raid by 15 seconds. Oh, that's okay. No worries. Yeah, sorry. I should have started a couple minutes earlier. I was making myself from dinner. Yeah. Nice. How'd your stream go, Zach? Nice lesson. Good. Yeah, he does things with, like, I think today's stream is like using math to do things or something, right? I think it's awesome. Boom, boom, boom. All right, there we go. What's up, Kasey? Nice. Okay, yeah, today is Tuesday. Last stream of the week, because I gotta fly out tomorrow.
Bruh. You done messed up, Aaron!
Ooh, recursion? Yes. Geometric sequences. Recursion is like super useful for coding. A lot of coding stuff is really nice if you know how recursion works. You got 100 on your physics paper 1 and 98 on physics paper 2. Fuck yeah, dude. Good job, Kasey. You post a screenshot in the Good Grades channel. I'll give you credit for it. I made myself some dinner. Does it look kind of tasty? Right? Oh, it's funny. You know what? The green from the cilantro is, it thinks it's my green screen. So it's going through. Recursion in programming is mostly trash. I mean, it's very hard to come up with, but when it does, it's quite beautiful, right? I agree more times than not. If I have to do something that needed to be done recursively, I would just brute force it with a bunch of like for loops. But like sometimes the nested for loops that are recursive, it's pretty. It's very beautiful to see if it happens. But I agree. In like practical coding, we don't really ever use it. I can't think of the last time I actually used recursion in code that I wrote, or code that I told ChatGPT to write. Zach was programming in Python. What was he programming in? Code I wrote. I know. I do still write some code these days, but not all the time. Yeah, it's just ChatGPT can write it faster. Okay. All right. So yeah, today's last stream of the week. We'll resume streaming again on Monday. So if you guys got any math science questions, today's the day to do it. Otherwise, do not worry. We have other friends that are also streaming math and science. Again, if you can always just go to the calendar here, check out the sketch. Looks like Zach's doing DiffyQ tomorrow morning, and then Penn Center's doing Riemann surfaces. What is this Rage Against the Machine Learning series? I want to know what this is. This looks fun. And then Zach will also be doing more math and science help on Saturday. So I finally went back to publishing TikTok videos or like tutorial stuff, and I'm actually they've been doing pretty well. Let's see what are they doing on TikTok. Let's just go check. Keep you guys involved in like. All right, so cool. We're at 1,000 views on TikTok. It's kind of low, honestly, but I haven't posted something on TikTok in over a year, so it takes time to build up the momentum. Let's see on YouTube. How are we doing on YouTube? Let's see, shorts. So I got a couple scheduled. Oh, wow, almost 3K. Hell yeah, dude. That's great. We like that. Yeah, 3K views. That's pretty good. I've made 21 cents. Wow. Beautiful. That'll fund the whole server. So, yeah, this is... Oh, we got 6 subscribers from it. Cool. Yeah, so I took this big video I did on... That's ChatGPT. Sorry, what am I looking for? The whole video... You made money from Minecraft? People make money from... what was it? RuneScape, apparently. In Venezuela. Like because the cost of, because the average income in Venezuela is so low, they actually rely on using RuneScape as a legitimate way to like make a living. And so they got really mad once like the power was out or like the internet was gone because they're like, wait, shit, we can't make any money. But yeah, I made this video about kind of like inverse trig and trig functions. It's just something I always find myself having to explain. Like, how do you take the sine of arc cosine or something? So I made a fun little video to explain it all. And then, so the full video is like 3 minutes long. But what I realized is people on YouTube, especially on shorts, don't really want to wait for all 3 minutes. So I broke this up into 3 different sections. So one of it's like, oh, here's how to just find out what the arc sine of something is. Here's how you find the cosine of arc sine of something. And then here's how you find cosine arc sine of like a variable. So... and I scheduled those to actually, so I got 3 videos for the price of 1. But on TikTok, I don't like doing like part 1, part 2, part 3, because you can't really link, like go to the next one, but on YouTube you can. So when you post like a YouTube short, you can have a related short to it. And so I'm just going to drip feed this week, part 1, part 2, part 3, and then just have 1 point to 2, 2 point to 3, and then 3 points back to 1. Yeah, it's YouTube shorts, yeah. But I mean, YouTube Shorts at least pays me. TikTok isn't really paying very much these days. But yeah, cool. All right, so yeah. All right, let's see. StarPod's already got a question on the queue. So without further ado, let's go learn some physics and maybe some math and help you guys out with homework. Okay. Cool. All right, welcome everyone to Office Hours. My name is Dr. Golden Sachs Education. Stream that helps you out with math and science homework. All sorts of fun stuff. Yeah, physics. Physics. I love when we do physics. This was from yesterday. Yeah, this was science from. We're gonna do your question first. Let me just get all the chats working. Physics, the best subject. Goated, honestly. Yeah. Okay, can you go over here, please? Thank you. Okay. Let's go to the queue. Starprod. Prove the following. Ooh. This is not physics. I guess it's kind of physics. I love AI for repetitive homework because it works perfectly. I don't know about perfectly, but it does work pretty well. It's not perfect though. But yeah, I this is why I always tell people, you guys have such like life hacks these days for how to study for classes and tests, because you can literally just have AI just generate thousands of example problems, and it'll even like come up with the solutions. You really do get like a, you know, nothing's as good as like a human one-on-one tutor for sure. I understand, but for those that like can't afford it, or you know don't have the time or whatnot to like schedule someone, AI is fucking great. Like, you guys live in like the best era. I mean, the best and the worst era, unfortunately. I mean, there's a lot of other shit going on that's like not the best, but. And you can have conversations. I mean, that's a good thing and a bad thing. It becomes a scary thing because then people start having like conversations with AI, not with other humans.
You done messed up, Aaron!
So, okay, prove the following. K plus CU is equal to KU plus CU. Okay. Well, these are always just like magnitudes, right? I'm curious, like, how much you have to do to like prove this. I mean, yes, by the distributive property, you could literally just say that K plus CU is KU plus CU. But maybe we should like show it. It is literally the distributive property. But maybe let's show it with like vectors. That'd be kind of cool, wouldn't it? I don't know. Like, let's say that integration by parts, totally. Alistair, not Alistair. You want to submit the queue's only one question long, so if you want to submit a screenshot of a integration by parts problem, I'll 100% just like walk you through it. Just give me something to work on that's integration by parts. You can go to Google and type in like integration by parts problem if you really want. Okay, let's like let U be equal to a vector, okay, which would be like x comma 1. Yeah, we have two Alistairs now. Well, he's Alistair. Alistair is different than Alistair. And then yeah, sure, let C1 and C2 be constants. Okay. We could talk about like maybe the magnitude of U, right? I don't know, it could be kind of cool, right? So I don't know, magnitude of U equal to the square root of x squared plus y squared, maybe, right? So magnitude of C times U, right? Let's just say C1, right? Would have to be the square root of like C1 x squared plus y squared, right? K and C are scalars. They are scalars for sure. They are scalars. I think what I want to show here is that C1 U vector is just going to be C1x, comma, C1y, if that makes sense. This is linear algebra, I guess, yeah. It's basic linear algebra. This is a very basic proof. I'm just trying to come up with like a cool way to do it. Right, okay. So, if we considered C1 U vector, right, or the magnitude of U, this would be the same as the magnitude, this would also be the same as C1 squared of x squared plus y squared, which would be equal to the square root of C1x squared plus C1y squared, which this is a new vector, right? Where its x coordinate is now just c1x, and its y coordinate is now c1y. I can definitely do an inverse trig integral. Yeah, Alistair, give it to me. Okay. And I think this is a way of showing, so c1 u vector is just equal to like c1x comma c1y. Maybe it's not like a rigorous proof, but I think it's kind of a cool thing that shows it, right? And then, you know, by the same logic. Sup, nerds? C2u, right, would be equal to a vector c2x comma c2y. You have your physics exam in 2 days? Good luck, dude. Laplace transforms. Ooh. I can. Those are a little bit harder, but I can definitely help with them. So yeah, if you want to submit a screenshot, the website there, actualofficehours.com. Submit me an example of a Laplace transform question you need help with, and I'll show you how to do it. Okay, so I don't know. Cu vector plus c2 u vector would be the same thing as c1x plus c2x comma c1y plus c2y. Skitsy is your name? Yeah, I see your skits. Yeah, I see him. You'll get a notification that I got uploaded, and also if you look here at the if you go to our website, you'll see on the queue. Yep, see, there you go. There's 3 of them. Wow. All right, let's wrap this, and then I'll help you guys out. Okay, and this is the same as c1 plus c2 times u vector. So I think that this proves this is equal to this, right? Because here, this is also equal to c1 plus c2 x comma c1 plus c2y. What's up, Sam? Cheers, Sam. I haven't seen you in a while. Yeah, you can totally do that too. Okay, cool. All right, I think it's a good explanation. Let's work on the other one. All right.
Well done.
Okay. All right, Jaws, you're next. I'm not too cooked. I'm glad you're not too cooked. You're what, like half baked? Slightly roasted? All right, let's see what Jaws got for me. Ooh, wow, dimensional analysis. This is fun. I like dimensional analysis. I think dimensional analysis is pretty sick.
That's dope.
Okay, use dimensional analysis to determine how the time taken for heat to diffuse through a body depends on the size L of the body and its thermal diffusivity. Hence, answer the following questions. If it takes 6 hours to defrost a frozen chicken, how long would it take to defrost a woolly mammoth? Oh, okay. Okay, well, size L of the body. I'm assuming that L is in, like, meters cubed. Why is the quality so low? Quality of what? What's the most important topic in advanced functions? I don't know. You'd have to send me what the advanced functions class is exactly. I don't know what that is. Been watching all streams, just no channel points. Okay. All right, so L is probably in meters cubed. Let me figure out what thermal diffusivity units are. Thermal diffusivity units. You get 10 extra credit? Fuck yeah, dude. So wait. Okay. Is in watts per meter. per degree Kelvin. Yeah, okay. Watts per meter per Kelvin. Okay. Okay, so K is equal to watts per. Or here, let's put like script K. I can't really draw script K. Here, I'm gonna say like lowercase is equal to meters in Kelvin. Okay. So, and we need time. So here's actually the cool thing. So let's think about like what watts are. So watts is equal to joules per second. Okay. So this is really joules per second and then over 1 meter Kelvin. And we want to know how time depends on it, right? So at the end of the day, we're looking for like T is equal to something. Thermal diffusivity is in meters squared per second? Really? The internet says otherwise. Are you right? Oh, it is. Oh, meters squared per second. Okay. Oh, I was looking at thermal conductivity. Okay. All right, thanks. All right, whatever. It's okay. Meters squared per second. Okay, fine. Sure. Okay. And so we need something where like time is equal to something in terms of seconds. So how would we manipulate this to get something in terms of seconds, right? So we would probably need to divide by K, right? That would get us seconds over meters. So I could say like 1 over K at least, right? And then I don't I don't want meters to still be there. So 1 over K would get me 1 over K would get me seconds over meters squared. So then I think I need to multiply by length to the 3/2. Right? Or not length, sorry, size. Yeah. Or no, length of the 2/3. Sorry, L to the 2/3 is what I want. Sorry, 2/3. Yeah. Because once this comes in, then you have S over M squared, and then this is M cubed to the 2/3. And exponent to an exponent means you multiply the exponents, and 3 times 2/3 is just 2. And then these cancel. Okay, cool. So, I need 1 over K times L to the 2/3. In reality, it's probably like some... I mean, this is like a cross-sectional area is usually what we deal with. But okay. Okay. Cool. All right, so that I think that's like what we've determined, is that time is proportional to L to the 2/3 over K. Yeah, it's pretty abstract. It's a cool problem, though. I mean, so a lot of times, even on like the SAT and stuff, if you're seeing questions and you don't remember the formula, you can kind of just think about what the units are and then make sure that the units make sense. Like in this case, I know I need something. This is a good exercise for understanding things. Okay. Yeah, dimensional analysis is very useful. Incredibly useful. Yeah, it's one of the best things ever. Okay, so if it takes 6 hours to defrost a frozen chicken, how long would it take to defrost a woolly mammoth? Okay. I guess we can assume that the thermal diffusivity is the same of a chicken and a woolly mammoth. I know they're probably technically different densities, but
No.
whatever. They're both like mammals. They're both, you know, biological things. Watch the glaze. Funny, dude. Okay, so here's what you can say. You can say that, okay, T1 is equal to, or here's what we can say. So T1 is equal to L1 to the 2/3 over K1. And then if we divide that by T2, that would be dividing by L2 to the 2/3 K2. And what we're going to do is we're going to assume, this is for part A, assume that K1 equals K2. It's an avian? Yeah. Oh, wait. Oh, I guess it's not a mammal. You're right. Yeah, it lays eggs. I forgot about that. Yeah, okay. This is why this is why I don't teach biology. What's up, gang? What's up, X-Man?
Yeah.
Okay, cool. So T1 over T2. Bro's been doing too much math. Yeah. I've forgotten about just basic biology. L1 over L2. And this is why the birth rates are declining. No. We're doing too much math. Okay. I think I just need a relationship between L1 and L2. So between a frozen chicken and a woolly mammoth. Okay. What do we think the size difference is between a chicken and a mammoth? Maybe a factor of 100? Your second born son? I'm not like a doula? I'm not a doula. That's what it is. Okay. I think it's 100. That seems like reasonable. But let's look at this. Let's say like volume of a chicken. A typical hen displaces around 2 to 3.5 liters. Okay. Okay, so there we go. Here's it. Okay. 1287 centimeters cubed. Let's say the volume of a woolly mammoth. A volume of oh, they're huge. Okay. Can we estimate it as a spherical woolly mammoth? That's always the joke in physics. Everything's spherical. Okay. All right. Well, roughly the size of modern elephants. Oh, okay. Let me see. Okay, volume of a modern elephant. There we go. Elephants have volumes of roughly 3 to 7 cubic meters. Okay, I like that. I cannot do your tax forms, Alistair. Okay. So, here's what we're gonna say. So, L2, which is the mammoth, let's just say that's 5 meters cubed. And then L1, which was the chicken, I think we saw was 1,300 centimeters cubed. Okay. Now, before I can put this in here, these need to have the same units, right? So, this is more dimensional analysis. I want to convert this, I think, into meters cubed. So what I'm going to say is like, okay, how many meters cubed is equal to 1,300 centimeters cubed? And what you can do is we know some conversion factors, right? I know that there's 100 centimeters in 1 meter. But then I need to do this 3 times. The reason why I need to do this 3 times is because I need centimeters cubed. So when I need centimeters cubed, it means I need to do the conversion of centimeters 3 times in a row. So, guy with the flu is back online. I am back. Yeah, okay. So this is 1,300 over 10 to the 2 times 10 to the 2 times 10 to the 2, which is 10 to the 6. So actually, we can just estimate this real quick. So 1,300, that's the same thing as 1.3 times 10 to the 3. And then we have over 10 to the 6. So this is equal to 1.3 times 10 to the minus 3 meters cubed. Beautiful. Okay, so now we can convert some shit, right? So this is 1.3 times 10 to the minus 3. All to the 2/3. That's the chicken. Over 5 to the 2/3. And we need to get a number for that. So let's go find our calculator. Okay. Sorry. 1.3 e to the minus 3. We're going to divide that by 5, and then we're just going to raise everything to the 2/3. Okay, that gets us 0.004. So T1 over T2 is equal to 0.004. And then we said how long? It takes 6 hours to defrost a chicken. Okay, so T1 is equal to 6 hours. So now we can plug that in. So 6 over T2 is equal to 0.004. So now if I just swap these, I get 6 over 0.004. It is going to be a lot of time. It's equal to T2. So 6 divided by that. Okay. And that's going to get me 1,473 hours. Okay. Nice. A lot of time.
I think you need that gold.
I do. Thanks, Jeff.
You're like dying over there, bro.
I'm dying. I am fucking dying, dude. Okay. Let me see what this says. Cookery books. The books on getting cooked. The cookery books state that the time taken to cook meat is, for example, 20 minutes per pound plus 20 minutes? Is this correct? Well, you really have to plan ahead if you want to roast a mammoth, yeah, apparently. Yeah, what, 1,400 hours? How many days is that? That's like 70 days, right? Yeah, you're just thawing it out for like a couple months. Right. So, but volume is related to weight, right, for the cookery books? Oh, I see what you're saying. Yeah. Yeah, I would say this is, like, not correct then. Yeah, sure. I mean, size is... I mean, if you assume the density of all your stuff is basically the same, which you'd be surprised. The density of, like, most liquids that we consume as humans are all the same. Everything is about, like, 1 gram per centimeter cubed. Doesn't matter if it's, like, ranch or, like, water. It's all kind of the same. I would say. But in any case, the fact that there's an offset, so they're saying this is like 20x plus 20. This is incorrect.
Bruh.
Because that's saying, for instance, if you had 0 pounds of meat, that it would still take 20 minutes. That doesn't make any sense, right? It takes 0 minutes to defrost 0 meat. So I would say, no, this is incorrect. Exactly. Times the mass, yeah. So, I think just having any sort of offset doesn't make any sense. But okay. Cool. Good question, Jaws. Yeah, we don't know anything about the pounds and whatever. So, okay, cool. So what we're going to do, we're going to go to the next question from Skits. So thanks for hanging out, Skits. Oh, man, what? I got to go... One sec. I got to go log in. What's up, Ricky Bobby? What's up? One sec. I got to go clear some room. Manage files. Here we go. TikTok workbook. Yeah, let's clear the clipboard, I guess. Hopefully that doesn't clear this. Okay, this was Jaws. Okay, so Jaws, what we're gonna do is, because you asked a question, we're gonna put that into our Discord server. So for those of you watching, make sure go join our Discord. It's awesome. You can get prizes and rewards and all sort of fun shit. But anytime we do one of your questions, it gets put into our server, into this little channel here called Homework Help Screenshots, or sorry, Homework Help. And then once it's there, I take the workbook of like whatever we did, and it gets put back into here. Nice. And if you claim this is your question, you get a point in my Discord. And then with the points in the Discord, we buy you gift cards and all sorts of fun shit. Okay, all right. Let's see. What was the how can you send photos? Great question. So the way to do that is this website, actualofficehours.com, which is down there below. You should see the link for it. I can't post links in most TikTok things because they get mad at URLs. But if you drag in screenshot of your question, type your username, hit upload, and then it'll get added to the queue here. So great. Let's see what we got next for skits. Skits. Oh, this is physics. Okay, I'm having to like cock my head sideways, but we can do this. Okay. All you need is part C? Sure. Okay. Let's see what we got. I like that it's gold, by the way. What does gold mean? I'm a big fan of this. Okay. An arrow is fired horizontally 28 meters per second from a point Q at the top of a tower. Another arrow it was made for me, is fired from point B, right, at an angle. Great. The ground is modeled as a horizontal plane and 2 arrows. Okay. Okay, sure. Find, in terms of H, the horizontal distance from the tower to the point where the paths of the arrows intersect. Ooh, this is very cool. I really like this. This is really fun. Okay. Cool question, by the way, Skits. I like this. So, big picture, I think I'm going to figure out what the height of, for instance, the bottom thing is and what the height of the top thing is as a function of time. And then I'm going to try to figure out at what time they both have the same height. And then once I have that, I can then also calculate what the X position will be. Yeah, it did, StarPod, right? Yeah. Right, you guys were saying yesterday, where's all the questions? I was like, it's a holiday. No one wants to ask questions on a holiday. Now it's not a holiday, and suddenly the Q is 8. Yeah. Okay. So let's talk about, for instance, the Y position of Q. I'm gonna say like YQ. Okay. So from my kinematics, I know that YQ is equal to the initial height, which is 8. And then that's going to be plus the initial velocity in the Y direction, but there is no initial velocity in the Y direction. Can you do it using the knowledge I know? I do A-level math, so we use SUVAT. Okay. Well, this is SUVAT. I'm basically using SUVAT. Do you want me to, like, figure out... Let me pull up what the SUVAT equations are. And then I'll show you which one I'm using. Here we go. Yeah, horizontal is equal to S. S equals VT. Yeah. But then this, right? This is what I want to use for the vertical stuff, right? Well, actually, wait. What? No, I want this one. Sorry. That's funny. You guys have this one as well. I get it. The minus sign. That's cute. Okay. This one. And here's what I'm going to say is that S is equal to, we're going to say like final position minus initial position. Okay. Is that okay? So, really the position this thing is going to be at is going to be, I think I want to say this. It's going to equal the initial position plus S, right? So YQ is equal to H plus S. Does that make sense? Right? It's the height, the initial height you're at, added to like what your displacement was. And so that's going to be equal to H plus UT. There's no initial velocity in the Y direction for Q because it just goes horizontally. And then A is going to be negative 9.8. So this is going to be minus 4.9 T squared. Okay. So that's the Y position of the Q particle as a function of T. Okay. Now let's look at the Y position for particle P. Okay. So YP is also going to equal its initial position, which is 0 plus S. And that's going to equal to 0 plus, and then this thing does have initial velocity in the Y direction, right? So for what we can say for VPX, which is also going to equal VPY, that's going to equal to 28 square root of 2 over 2, which is equal to 14 square root of 2. How I got that is because this is being shot at a 45-degree angle. You know, you have like VX and you have VY. this is an isosceles triangle because 45, 45, 90. So this velocity will be equal to this velocity. And then you use trig to figure out like what this is. And so for instance, if this was v, right? You could say the sine of 45 degrees is equal to opposite over hypotenuse. And so Vy just equals V sine 45 degrees. And then what you learn from the unit circle is that the sine of 45 degrees is equal to square root of 2 over 2. You were just doing that? Oh, cool. Good. So this is just equal to V square root of 2 over 2, which is what I did over here. Right, this was V square root of 2 over 2, and then 28 over 2 is 14. Let me know, Skits, at any point if I'm like going too fast or skipping too many steps. I will hold the bus up, you know, and make sure you understand it. So cool. All right, so that's 0. And then we're gonna say plus 14. Oh, let me get my thing better. Plus 14 square root of 2 t. Right, that's the initial velocity, and then minus the same, minus 4.9 t squared. Yeah, I know how to do all that, bro. I just got real stuck. I got an equation involving h and t. Yeah, great. Okay. I don't know where to go from there. Totally cool. So what you want to know. So we want yq to equal yp. Right? I need the height of q to equal the height of p. So I can set these two things equal to each other, right? And so what I'm going to get is that h minus 4.9 t squared is equal to 14 square root of 2 t minus 4.9 t squared. Great. Okay, cool. Right? This cancels. So you get h is equal to 14 root 2 t. Cool. Now you're right that this is the unfortunate thing here, right? Is that we have two unknowns. So I need a second equation. So what I need to know is I need xq to also equal xp. Yeah, you can Oak Spirit for sure. Just submit it to the queue. Because not only do they have to have the same y position, they also have to have the same x position. And I think that's what we're asking for, right? Where the paths of the arrows intersect, yeah. Oh, I see what you're saying. It's only where the paths intersect? Uh-huh. Oh, okay. I originally thought we were going to figure out when they collide. That would have been so cool, though. Ugh, fine. That's boring. Okay. Well. Okay. Yeah, the wording is a bit confusing in this question. Yeah, they just want to know where the paths of them intersect. Okay. So they want y as a function of x for each one, right? That's all they want. Correct. They are going to hit at different times. Yeah. So now this assumption here, you can't use this. Yeah. So what they want is they want y as a function of x for the first thing, and then y as a function of x for the second one. And then you want to figure out the x coordinate where the y coordinates intersect. But it's independent of the time. Okay. I think I want to do that. Okay. It's okay. This is like TP. So, we don't want YQ to equal Y. We do want YQ to equal YP, but we need these things not in terms of time. Okay? And the way to get that, let me think. I don't have final velocity, right, guys? No. Okay. I think what I'm going to do is I'm going to have expressions for the x position in terms of t. Exactly. Yeah, you eliminate to get the parabolas, yeah. So here's what we say. So in both cases, right? So for xq, which is just equal to 0 plus s, right? Because they start at x equals 0. This is just equal to 28t, right? Yeah. So this describes the well, this is displacement in the x direction, yeah. Wait. But we do want those to be the same. Yeah, okay. Also, I hate that you guys use s. This is terrible.
You done messed up, Aaron!
I don't like this. Because I gotta say, like, this is displacement in the y direction, right? sy. But okay, whatever. Okay, so xq is equal to 28, and we can say this is like tq. And then for the p particle, right? This is also 0 plus s, which is equal to the x component of the velocity, which is 14 square root of 2. Not to mention it should be, yeah, again, so I don't like SUVAT. I think it's kind of whack. I get that it's a clever acronym, but who gives a fuck? All right, this is equal to TP. All right. So now I have expressions for what the time in the P, for the P particle, and what the time for the Q particle are in terms of their displacement in the X direction. Okay. So for here, so for this one, we get that, so xq over 28 is equal to tq. And then from this, we get that xp over 14 root 2 is equal to TP. Now, I can plug these in for each one of these, yeah? It's kind of a weird question. It's cool, though. Okay, so, YQ is equal to H minus 4.9. And then that's going to be XQ over 28 squared. And then YP is going to be equal to 14 square root of 2 times XP over 14 root 2 minus 4.9, and then we're going to say XP over 14 root 2 squared. Is this good so far? I think we're almost there. We're very close here. If this makes sense. Let me know, skits, if this is making sense. I hope it is. Yeah, okay, cool. So, now what I know is that YP equals YQ, and also XP equals XQ, right, for the paths to collide. So I'm just going to call, whatever. I'm just going to call this X. And I think if I set this equal to this, watch what we get. So I get this, and now this is no longer XQ, so it's just equal to X. I didn't give myself much room here, did I? Okay. All we gotta do is go solve this. Kind of sucks. All right. This cancels. And then eventually I want to solve for X. So this is going to become a quadratic, skits. I'm trying to see how I want to do this. Okay. I'm going to move this over. So I'm going to say 4.9. I'm going to do some grouping here. Because it's 4.9. And then it's going to be 1 over 28 squared. No, sorry. 1 over 14 root 2 squared. So 1 over 14 squared times 2. Minus 1 over 28 squared. X squared. If we move that over, right? Then we're going to say minus X, because then this will just come over. And then plus H is equal to 0. Okay. And now I need this. Now this is a quadratic. Let me just come up with a number for this, because I just want something that's nice. It's pretty ugly. Okay. So 4.9 times 1 over 14 squared. And you gotta be careful on the calculator here, because I have to say this is also like times 2. There we go. That respects that. Okay. Minus 1 over 28 squared. Oh, not tangent. Cool. Oh, wow. That's actually a really nice number. No way. Really? What is that? That's like 1/80th or something? What is that? Right. A 1/160th. Yeah, I was like, it looks like 1/16th or something. Yeah. Okay. Cool. It's actually really nice. I don't know how that happened, but I guess it did. Did I do that right? Yeah. 1 over 2 times 14 squared. Okay, fine. Okay. So, X squared over 1. So 1 over 160. X squared minus X plus H is equal to 0. So now you just do the quadratic. It is projectile motion. Meson, yep. So you get that X is equal to negative B, which is 1, plus or minus the square root of this squared. So 1 over 160 squared minus 4 times 1 over 160 times H. And then all over 2 over 160. So what, that's 1 over 180. Okay. And then, because there's 2 solutions, you want the positive one, right? Because here's what happens, right? This thing has parabolic motion that looks like this. And then this kind of has, I guess, parabolic motion that looks like this. Oh. I guess it could hit later, though, no? Right? Oh, man. So maybe you want the first solution?
Disqualified.
This is a weird question, dude. Wow. Trust it to the UK, man. To just give, like, fucking benders of questions. Yeah, you gotta check Y for both. That's annoying. Yeah, because you gotta make sure Y is positive. Fuck. So, I don't know what. This is 80. 80 plus or minus the square root of 80 plus 80 square root of root. Plus or minus square root of 1 over 160. Oh, B squared. Sorry. No, this is not 1 over 160. This is this is just 1 squared. B squared minus 4AC. Yes. Okay, B squared. This is negative 1 squared. Oh. Much nicer. Okay, I was looking at this. I was like, man, I don't really want to do this. Okay, minus 4AC. So then this is 1/40th H. Okay. This is more reasonable. I think what we need to do then is check Y for which solution gives Y is greater than 0. Okay. I think I want to choose this one. Because they're both equal to each other. Okay, so remember, right, that Y was equal to this. So if I plug could you do it another way? In A-level Edexcel math, we have formulas you can use. It forms like a quadratic, but it involves tangent and alpha. Yeah, I remember I saw a similar question to this at some point. And I think the tangent part comes from relating Vx and Vy as sine over cosine. Yeah, it's the same method, just with a general angle and an initial velocity. Yeah. So wait, let me go see what equations you get. Yeah, if I can see what equations you get, that's cool. What is this? A-level physics equation sheet. Yeah, x tan alpha minus gx squared 1 minus tangent squared 2. Yeah, yeah. I know where that's going to come from. I don't see that equation, though. Oh, it's Edexcel A-level math. Sorry, what is Edexcel? I've heard this thing before. Edexcel A-level math formula sheet. It's one of the exam boards. Oh, okay. Trig. Mechanics, maybe? Is that what you're saying? Because this is a physics question is what it is. I'm looking for it. Might be in further maths? Okay. All right, let me think. Let me just think what I know what that equation is. It's almost never used though. It's such a weirdly specific one. Let me think. Equation of projectile. What's up, Snazzy?
Good job.
Projectile motion, initial velocity, and angle, y. It's normally meant to, yeah. to model a parabola. Was taking calc too?
Good job.
Oh, welcome back. Welcome back to the stream, Snaz. Here we go. Projectile motion parabola equation. All right, is this it? This like nasty thing. Oh, here we go. Got it. Okay. This is like the proper way to do it. I guess there's also this. Yeah, you're just eliminating time in terms of Vx and Vy. Okay. So for... Yeah, this is... Oh, that's what you guys did? It's just weird. I've never seen that in, like, American physics stuff. We usually do it this way. Alright, so wait. Q has, Oh, what we did on... Oh, you're saying, like... Yeah, exactly. We just didn't keep the... We didn't keep the angle in there. Right? Because for Q, alpha is equal to 0. And then V is equal to 28. But then also you have to, like, add plus H. And then for P... Alpha is equal to 45 degrees. V is equal to 28. And you don't. So for the Q equation, and then, yeah, tangent of 0 is 0. Oh, okay, yeah. Well, yeah, this is exactly what we did then. Yeah, no, it's the same thing. Right? Yeah. Because this is it. This is the exact same thing. You're adding height. Yeah. Yeah, so, Skits, these two equations we got here are the equivalent to this equation here. We just plugged in for variables, and we also, like, gave an initial height. I think this is the only way you can do it, though. If you set them equal to each other, you get a quadratic for x, and then you need to check which one gives you a positive value for y. Here, I'll put this up here just to. This also gets you the same thing. Okay. I think we just need to do this. So if you use that one, why would you need H for Q? Because this assumes that the starting height is 0. Right? Because watch what happens. If you plug in x equals 0, right? This goes to 0, this goes to 0. And you should get y equals 0, but you don't. Right? When x equals 0 for the Q particle, you also need a plus h. Because it starts at a height h. This is the displacement from its initial y. Good, yeah. So the change in displacement is y minus h, yeah. Well, change in displacement. Well, let me think about that. Sorry. Change in displacement. Yes. Yeah, sure. Yeah, because delta s plus h equals y. Yeah, that's fine. Okay, so you need to plug this into here, I think, and then see like which one gets you the positive solution. And yeah, you use the angle as 0 for them, right? Yeah, and then the other one is 45, and that's all we've done. We've accounted for that.
Nice.
So when you plug this in for here, okay, we're going to get h minus 4.9 over 28 squared. Yeah, for sure. For sure, Trekt. There you go. That's it. Oh, I spelled submit wrong. There you go. Okay. H minus blah, 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 blah squared. And then it's this squared. So then it's 80 plus or minus the square root of 1 minus 1 over 40h squared. Oh, man. And I guess I'm trying to see, like, which one is positive. Isn't that also going to depend on h? It's a mess. For sure. Okay. This is 80 squared. The plus minus doesn't matter here. Yeah, sorry, there is an 80 times the square root as well. Yep, thank you. Oh, so let me pull the 80 squared out. Right? Let me just pull it out. Now this is 1 plus or minus. H is on the top, right? Yeah. Okay. So. I see why this is a gold level question. All right. This is going to be 1 squared, which is just 1. And then plus minus squared is still going to be like plus 1 minus 1 over 40h. And then the question here is, it's either like plus minus 2 times the square root of 1 minus 1 over 40h. Right? So, this is going to get you 2? Man, this just doesn't look nice. 2 minus 1 over 40 h, and then plus minus this. Okay, and I need this to be greater than or equal to 0, right? I don't really see a nice way to solve this, Skits. And I don't want to trudge through the algebra of making another quadratic out of this. Yeah, group the terms that depend on h and don't. Yeah. Well, yeah. So this doesn't depend on h, right? But this does and this does. You think they just take the positive version? Yeah, so let's think. You want y. So, also, it depends on h, right? So, like, let's say for example, h equals 40, right? Then you would get 40 minus this whole nasty grab bag of things, right? And then this would be 2 minus 1, plus or minus 2 square root, and then this is 1 minus 1, which is 0, right? Okay. Oh, well, I don't want the I don't want it to be actually. All right, let's make it 20. Sorry, make it 80. Just so I can. Oh, and actually that doesn't work. Oh, there's a limit here on h, right? H can't be greater than 40. Aha. Oh, doesn't work. I guess that makes sense. That's actually kind of cool. Yeah, the max height is 40. Yeah. That's cool, actually, from this. Yeah. So that tells you, right? Yeah, max height is 40. Oh, sorry. Is that what they did in part A? Find the maximum value. Okay. So if age was equal to 20, maybe, right? Whatever. This is 20. And then this is 2 minus a half. Plus or minus the square root of 2. Square root of 1/2. So, this is obviously going to be bigger than this, right? 80 squared over 28 squared is much bigger. This is going to be 3/2 plus or minus 2 square root of 1/2. You need this to be negative in order for this to turn into a positive, so then that you get positive y. So I think you take the minus. Right? Because square root of 0.5 is that, right? Times 2. Oh, that doesn't even get you negative anyways, though. Fuck. Okay. I'm curious. Let me just see what chat says this. Good job on you giving me a stumper of a question. I'm gonna like move forward though, because I have to. There's so many questions in the queue. This is tricky though. You asked chat so many times. Yeah. It should be able to get this, though. They said the minus sign. This looks wrong, though. I don't know where they're getting this 1568 from. Let's ask Gemini, actually, too. Have the AIs battle it. Oh, that's correct. Man, I didn't get the 786 though. I got some nice numbers. Or maybe the 786 comes from this. Yeah, and they said to use the negative root, which, yeah, I think the negative root is also the one. Because you want the first intersection point. Okay. We got to this, though. H minus G over 2. Oh, they keep things in terms of G. Oh, I see. Ah, because 9.8 over 392 is... Oh, wow. Oh, that's cool, actually. It is 1 over 40. That's very cool. Okay, cool, cool, cool. So yeah, I think we do have the same answer. I think we do. Dude, why is my clipboard not working? The fuck? Clip, please. There we go. But I don't want that one. There we go. Okay. Yeah. This is the same answer we got.
Oh, yeah.
And I agree. It should be the -1. Okay, cool. All right. Good. All right, at least hopefully that explains it to you a little bit. Thanks for the question, Skitsy. I guess you can assume that if it is going to hit twice, you want the earlier one. That'd make more sense, right? Because it's going to hit it once and then it'll hit it again when it's like below the ground. But, okay. Super interesting. All right, let's mark that one as done. And then here, I'll post all the work we did, Skitsy, in Discord, so make sure you join so you can go see it. That was a lot. Okay, let's see. What does Alistair got for me? Integral of arctangent? 1 over 1 plus x squared? I have a feeling that this is like the derivative of this. So let me look up what the derivative of arctangent is. Oh, it's 1 plus x squared. Okay. Okay, so now that we know that... I think I want to try to rewrite this to look like this. So I'm going to say that 1 plus 1 over x squared is the same thing if I multiply both here by top and bottom by x squared. That's 1 plus x squared over x squared. Right? So now we have the integral of arctangent of x times 1 over 1 plus x squared times x squared dx. Okay. And I think this is... Do x is equal to tan u? Oh, that's a funny one to do. What's your moderation skill? What is that? Wow. What's up, Moby? No, don't time people out, please. You don't need to time people out, Shaq. It's okay. Wait. The way I wrote arctangent is... Oh, yeah. This is really confusing. Sorry. Sorry. Tangent negative 1 of x. This is, like, super wrong. Sorry. I wanted to maybe say that, because I think Alistair was asking if this is integration by parts. Because I wanted to maybe say that, like, this whole thing is, like, one of them. And then I just need to reduce this down. Pinhead said, just dropped into Calc 2. A bit nervous as Calc 1 was a bit ago, and I'm having to relearn a lot. Any tips on the best ways to learn it quickly? Was Calc 1 just derivatives, or did you have like derivatives and integrals, Pinhead? I always forget like how they do things. Like, is Calc 1 derivatives and integrals, and then Calc 2 is like sequences and series? Okay. Then yeah, the best way to learn it quickly, probably just make sure you know how to do derivatives, because a lot of Calc 2, which is integration stuff, depends on you recognizing how to like what derivatives are, since integrals are like anti-derivatives. Let me see if I can do it this way. And then I might just make a substitution Hamiltonian. What's up, JC? So we do like u and then like dv. So let me say that u is equal to tangent -1 of x. Right? And then I know that like du is going to be 1 over 1 plus x squared. We need the math nerds. It took a while to relearn. Yeah. So make sure, and also a lot of trig stuff comes up, especially in integration. You can do a lot of like trig stuff. I feel like if this is u, then this is du, right? And then then dv is just because what is it? It's integral of u dv is equal to uv minus integral of v du. This is integration by parts. So I already have u. I already have du. Or I have, sorry. No, I need to get what so let me think about this, sorry. Oh, I think I know what to do. I think I say dv is equal to x squared over 1 plus x squared? Maybe? dx? No, that doesn't work though, because I don't know how to integrate that one again. Yeah, you want me to do that? Yeah, but then like, what is this fucking integral? This is another integration by parts. Integrate that by adding 1 and subtracting 1 in the numerator. Oh, I see what you're saying. This is the same thing as 1 plus x squared over 1 plus x squared minus 1 over 1 plus x squared. Beautiful, JC. Actually, yeah, that's actually really cool. Aha. Oh, that's really clever. Yeah, so you can do like plus 1, minus 1. So when you do that, you get this minus this. Okay. Okay. Right, and then the integral of this is just x. Right? And then the integral of this is that's tangent, right? Or arctangent. I was listening to some of your music and it was amazing. Is it possible you could use those for your streams? What music? What music are we talking about? Sorry. An integral of 1 plus x squared is arctangent of x. Okay. So this is x minus tangent -1 of x. Oh, the songs I make? Yeah, I just don't want to like get copyrighted on myself. Like, YouTube is super weird at just sending out copyright strikes. Even if I like own the music, they would force me to like prove it. So I don't know. I just use Suno to make music for background stuff. Okay, so there we go. So that's U. This whole thing was dV. So this is integral of uv. So that's going to be x arctan of x minus, dude, what, arctan of x squared? Minus the integral. Did this make our life easier, though? That's the question. Well, actually, yeah, this is actually doable, I'm pretty sure. Because this integral is easy, right? So this is minus the integral of x over 1 plus x squared. Yep, exactly. And then plus the integral of arctangent of x over 1 plus x squared. Yeah. This is a u sub, so you say u is equal to 1 plus x squared. Du is equal to 2x dx. Sorry. Don't forget the dx. Good. So it's really the integral of 1/2 du over u, right? Yeah, that was really goated. Yeah, thank you, JC. That was a really smart idea. I forget about that trick all the time. It's a good one. Okay, so that's that. So that's gonna be ln of u. So that's minus 1/2 ln of 1 plus x squared. Okay, so we did this part. So then we look here, and we say, okay, u is equal to arctangent of x. Du is equal to 1 over 1 plus x squared dx. So now this is just the integral of u du. So this is going to be plus u 1/2 u squared. So 1/2 tangent negative 1 of x squared. Okay, cool. And look at this. Oh, it would almost cancel out this one. Right? With this? The 1/2 is fucking it up, though. Fuck. Okay, cool. So, final thing. These come down. Is you get x arctangent of x. So that's minus 1 plus 1/2. So that's minus 1/2 arctangent negative 1 of x squared minus 1/2 ln of 1 plus x squared. Which I think is done. We can also throw this into, let's throw this into, or have Gemini chew on this. But I think it's pretty good. Plus C.
Surprise, motherfucker.
Oh man, dude.
Man,
I deserve it. I deserve
shut
that.
up.
I deserve that. I deserve that. Okay, cool. Awesome. Great. Cool. Cool question, Alistair. Alright. Let's download that one. That was Alistair's. Technically, it was integration by parts. Which is a very, very messy integration by parts. Let's see. I think, yeah. Look at that. And I think, yeah, Gemini got the same thing. That's cool. We love when that happens. Look at that. There you go. X tan minus 1/2. 1 plus x squared. Yeah, minus 1/2. Yeah. So this was the real, yeah, this was the money shot right here, dude. This trick here. Absolutely cool. I forget more times than none, if something looks nasty, just add 1 and subtract 1. And then you split it into 2 different integrals. And then this one was super easy to do. And then this is, yeah, also easy to do. Yeah, 0 marks for plus C. Yeah. That's terrible. Get out! Okay. I don't know why I have to keep logging in. Alright, Jeb, you're up next. What a fun one this one was, though. Very cool trick. All right, let's see. Next one on the queue is Jeb. Oh, this is some linear algebra I might not know how to do. All right, let's see who remembers linear algebra with me. Okay. The matrix below is the standard matrix of a linear transformation T. What are the domain and the codomains of this transformation? Ooh. I don't know. I don't know. Domain is usually like what what space it can act on, right? Yeah. R3 and R2. Yeah, so let's see. This is a what is it? A 2x3, right? So if you have a 2x3 for T, I guess if this were to act on a matrix, it could act on a 3x1, right? But then if something were acting on it, right, it would have to be a something by 2. So the domain is 3. R3. Yeah, okay. Right? Because whenever you're multiplying matrices together, for instance, if you're doing like a 2x3 multiplying by, I don't know, like a 3x6, this is allowed because the inner numbers are the same, and then your resulting matrix would give you a 2x6. And it okay, so if this is a 2x3, this means it needs to act on something that's a 3 by something. Okay, very cool. So the domain that it acts on is in R3. And then whatever it's going to produce is going to be a 2 by something. Is that what the codomain is? Is the codomain like the range? Okay. Is R2. Okay, cool. I think that's pretty cool. So this would be like what it acts on. Then this right here would be what it produces. Oh, we did, Alistair. It's quite tough. It's in our Discord though. So yeah, here's the solution. We did it. It was integration by parts. My bad, I was sleeping. Okay, well, good morning. Okay, is the transformation 1-to-1? Huh. 1-to-1 means that like for every X value, you get one unique Y value, right? So I think for every unique matrix that it acts on, you have to get like a unique resulting matrix, and you can't ever get the same matrix from two different X's. Okay. I did enjoy the challenge. Yeah, so T is going to act on like some like X matrix, and it's going to produce some Y matrix. And 1-to-1 means that every value of this only gets you one value of this, and you can't get the same value of this from multiple of these. What am I eating? I made some crisps. It was my dinner. I made some chippies. Some chippies. I think you guys call them chips, right? Potato chips. Okay. Approach from both sides, the left and the right, and meet. Is that what they say? What? Okay, if this acts on something in R3 and produces something in R2, I think it won't be 1-to-1, right? Because you'll have too many things in R3 and not enough things to map to in R2. I think something can only be 1-to-1 if it's R3 to R3, right? Yeah. If R3 maps to R2, then you have like how I would like kind of imagine it. Is you have a bunch of things here. And a couple of those will have to match to like the same thing in R2. I think it's how I would see it. These could be like two different things. And this would be the same thing. And that's not 1-to-1. Does T map the domain onto the codomain? Well, let's see. Oh, I see. You went ahead and got the whatever, the reduced echelon form of this. Okay, so this here is rank 2. Which tells me that the rows are not multiples of each other. So I would say yes, I guess. Yeah, okay. You can say yes. Rank 2, and the codomain is 2. Is R2. Find a vector X whose image under T is that. Oh, that's cool. This will actually be kind of fun. I like this part. And then here, let's get the row reduced form of this. 1 5 0 0 1 minus 1. Uh, 0 1 minus 1. So we want this times some vector x, which will create an image that'll get me -2 and 6. So here's the cool thing. This is a 2x3. This is a 2x1. So that tells me right away that this must be a 3x1. Because a 2x3 by a 3x1 will get you a 2x1, right? These numbers match, and these numbers are your result. Okay, cool. So right away, I know this is like x1, x2, x3. So in order to get that, so you're going to multiply this row by this column. So that's going to get you 1x1 plus 5x2 plus 0x3 has to equal -2. And then for this one, with this one, you're going to get that x2 minus x3. Oh, TikTok chat just spammed. It's okay. x2 minus x3. This is a linear algebra class. I'm pretty sure it is. I don't know who... this was Jeb's question. This looks like linear algebra to me for sure. Okay, fascinating. All right, we just have to come up with something that satisfies this, right? It's like whatever, right? What, so... x1 plus 5x2 equals -2. And then x2 minus x3 is equal to 6. So, you could say... Yeah, exactly. I would go one further. I would just define x1 to be something so that x2 is just 1. Right? Max, wouldn't that be easier? Let's just say like x1 is equal to... Don't you need to apply the row operations to b as well? Oh, you mean when I came up with this for the transformation? I don't think so. I don't think... Am I changing it? Oh, okay. All right, well... 150132. Okay. Just changes this one. It's okay. So what is this? x1 plus 3x2 plus 2x3 equal to 6. So I think we can, because we have, what is this, 3 unknowns and 2 equations, we get to fix one of the variables as being free. So, I'm going to choose, I like whole numbers. Yeah, it's 2 equations with 3 variables. Well, that's why there are a bunch of these, right? And this is also, this proves part B here when we said it's not 1-to-1, right? Because I have a bunch of different vectors I can act on to get the same image. That's how we know it's not 1-to-1. All right, whatever. Just say like x1 is equal to -7. Then x2 equals 1, right? And then if you plug here, x1 equals 0. Oh, that's another clever one. But then x2 is like a fraction. I don't really want that. All right, -7 plus 3 plus 2x3 is equal to 6, right? So 2x3 equals 10. So you can say x3 is equal to 5. What's up, fam? So in this case, -7, 1, 5 is valid. Nice. Cool. I think it works, right? Yeah, -5 plus... -7 plus 1 times 5 is -2. -7 plus 3 is -4. -4 plus 10 is 6. Cool. All right, good question there, Jeb. Appreciate it. It was fun. Good little linear algebra review.
Well done! Well done!
All right, Jeb, I'm gonna post that in our Discord right here, so you'll see your question come up. Where was it? There we go. There's Jeb's, and then here we'll drop the screenshot in. There you go. So yeah, make sure go join our Discord if you want to get access to all the stuff we're doing here. website. Same website you go to submit your questions. There's a link here. Join. Earn rewards. Have fun. Also, check out the streaming schedule to see all the other awesome streamers we have. Oh, I haven't given Zach a shout out, dude. What? I'm terrible. Or Obi. Wow. I've been slacking. I'm sorry, guys. There you go. Shout out to Zach. Zach's a great guy. He had a stream before us, actually, doing math through tasks. I think he was doing recursion, is what he said. And then tomorrow he has a stream on, like, DiffyQ. As well as some other awesome people. Penn Center's doing some stuff, so go check it out. Alright, next one is Tensy. Uh-oh, Tensors.
You done messed up, Aaron!
I don't know how to do these. All good, though. So wait, I'll wait. If someone in the chat knows how to do this, I don't know tensors. Thank you, Smash. I do need it. All right, Hamiltonian Dynamics says I do. Okay. This is for dude. JC, bless you for being up so late. I was just eating some chips I made. Okay. It's 3:49 a.m. for our friends on the other side of the pond. Okay, I'm gonna post this in our Discord. If someone wants to like take a stab at it. I think it's probably a physics sensor. That looks like a physics sensor to me. But it will be here. Hamiltonian, if you want to like write something up, take a stab for it. And then Tensy, if you're watching, this will be where you find the answer for it. If you write something up, I'll go over it. Night, people. Good night, JC. Thanks for stopping by, dude. Shout out to JC as well. He's a recent streamer. Newer streamer. Make sure go give him a follow. Convince him he needs to stream more chemistry for us. Okay, let me see. Gladiator Leos. Oh man, this question. Physics. Where's Jeff, dude? Is this too late for Jeff? Is this too late for Jeff's bedtime? Jeff loves physics. Where are you, Jeff? Alright. The lower block is pulled on by a rope with a tension force of 20 newtons. The coefficient of kinetic friction between the lower block and the surface is at. The coefficient of friction between the upper block is 0.30. What is the acceleration of the two? We need more midnight streamers. I'll be staying up. Nice. Jeff is afraid he'll make more mistakes. Yeah.
Motherfucker.
Can't keep losing all the years. Okay. So this is actually pretty cool. Because, okay, whatever the tension is in the rope this way, pulling this way, is also the same tension in the rope pulling this way on this block. Fascinating. Alright. Let's draw some force diagrams. I'm pretty sure that's usually how we start things. Okay, so this is the 2 kilogram block, which yes has 20 newtons pulling to the right. It's then gonna have T newtons pointing it to the left, and then it also has friction because this thing is moving to the right, but it doesn't want to move to the right. Friction's like trying to like pull it to the left. So this will also have, we can say like friction from the ground. Okay. And then let's label these. I'm going to call this like number 1. I'm going to call this one like number 2. Okay. That's the direct forces that are acting on it. Now, there is some other weird shit happening. Okay. So, it's mu k. Because all of this is kinetic. We assume that it's moving. I want to be very particular here, though. I need to say that this is the friction from the ground acting on it, because it turns out there's also going to be friction between the two blocks, and that's going to go this way for this one. I'll show you. It's kind of weird. It's pretty weird. Okay. Okay, then we have force of gravity. And then we're going to have normal force. Yeah. But then also, this is going to feel a force downwards. We're going to say 1 on 2. Because the block is up here, the block is going to exert a force on the 2 kilogram. And then this is the normal force from the ground. Right, yeah, weight of the top block, yeah. Okay, so let's make this one like brown. Let's make the other one like green. No, not green. Let's make it blue. Okay, so then we have the blue block, which is 1 kilogram, right? It's going to have tension pulling it this way. This is FN1. This is also going to feel normal force. And it's interesting, this is also going to equal, this is going to be F2 on 1, which is the same thing as F1 on 2. Yeah. And then it's also going to feel a force of gravity. Right, so normal force is always the force of the thing below it acting up on it. In this case, the thing below the second one is the first one. And so I like to say in this case that this feels the force of the second block acting up on it. And because of Newton's whatever second law, equal and opposite forces, this normal force that the 1 kilogram block feels pushing it up is the same normal force down that the 2 kilogram force feels from block 2, from the 1 kilogram block. Yeah, so that's kind of the key thing, is that these are the same. All right, this is the same as this. Oh, is it Newton's third law? I always forget which one's which. I think 1 is F equals ma. No, 2 is F equals ma. Okay, and then yeah, even though this thing wants to move to the left, friction is going to try to pull it to the right. So this is where we're going to say this is force of friction from the blocks. And this is another force pair. If this block feels friction trying to move it to the right, then that friction had to be provided from this block, which is going to feel it in the opposite direction. So this will not only feel the force of friction from the ground, it's also going to feel the force of friction from the blocks. It's kind of a weird thing. Yeah. They love this with the things on top of things. The classic one is, I think, when there's a car, right? It's got wheels, and, like, it's moving this way, and then there's a block here. And, like, as this thing moves forward, right, this thing wants to slip off, but the only thing that keeps it from slipping off is the force of friction giving it the acceleration to match the acceleration of the car. But then the car feels an opposite force of friction from the block being on there. And you can think about it also, like, in terms of, I don't know, just you know, if the block wasn't there, right, then the car should move easier. But if the block is there, right, then you got to think that, like, oh, there's like an effective force trying to like pull the car from backwards from not going too far this way. There's an effective force trying to slow down the car, and that's the force of friction between the block that's sitting on the back of the truck and the truck. Mr. Aegis, what's up, Mr. Aegis? Good to see you, Mr. Aegis. TKF host. Cool guy. I was there for, what was it? Shark Geeks podcast episode you guys did. He's a cool guy. We met at TwitchCon, me and Shark Geek. We got to get you out at TwitchCon, Mr. Aegis. One of these points. But nice. Okay, Gladiator, does this make sense so far? All the forces I've written out? It was a great convo, yeah. Nice, yeah. I love those types of like just open science discussions. They're fun. Looks good? Okay, cool. Alright, so now we gotta come up with... So there's so many forces here. Alright, let's just start getting some numbers on things, right? Okay. So sum of forces in the x direction. And then we have to like choose a direction for acceleration. Okay. This is kind of the weird thing. Meeting people IRL, that's too scary. I do meet people. It's awesome to meet people IRL, dude. I like to think about like what's the overall movement of this, because whenever things are connected by a rope, the like direction of travel is like the direction of travel of the whole thing, of like the snake. So I'm gonna call like this direction positive, which means this direction's negative. But then looking at block 1, right? That means this direction is positive and this direction's negative, right? Because as the rope moves this thing to the right, it's going to pull this thing to the left. And so the overall positive direction of motion, we're saying, is like counterclockwise. So this thing goes to the right, that's positive. If it went to the left, it would be negative. This thing going to the left is positive, and this thing going to the right is negative. Flashback to biomechanics. Last time I had to do physics. It's so funny. Yeah. Especially like pre-meds and stuff. They just dread this class. They just can't. They can't wait to get over it. They're just like, I just need to get it. I just need to get a 4.0 and just like be done with this. I never want to see it again. I'm like, but physics is really cool. This is annoying. I get it. This is actually a pretty super annoying question. But okay. So 20 newtons minus the tension. Minus the force of friction from gravity. So that's going to be minus, let's call this is FG1, this is FG2. So that's minus FG1. Oh, wait, sorry. It's minus FN1. Normal force times mu static. And then minus the force of friction from the blocks, which the force of friction from the blocks is going to be FN2 mu s. We'll get to that. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. And this is all going to equal M1A. Okay. Let's look at the sum of forces in the x direction for the blue thing. So, again, we designated this way being positive. This is negative. This is always handy to kind of do this. Put like what the positive and negative directions are. Because now tension points in the positive direction of acceleration for the 2 kilogram blue block. So this is going to be T minus force friction of the blocks, which is FN2 mu s. And that needs to equal M2A. And then if the things are moving together, they're going to have the same acceleration. So instead of saying A1 and A2 here, I'm just calling it equal to A because they're connected. Ali says, I feel like a failure for upgrading. What is your thoughts? What did you upgrade to? Did you upgrade to like Windows 11? What upgrade do you feel like a failure for doing? I'm curious. I refuse to update my Windows. I refuse. Windows 11 is a failure indeed. Yeah. What's the newest one? They keep trying to get me to upgrade. I really don't want to. Upgrading in high school before going to university. I think there might be a language barrier thing here, Ollie. What does upgrading mean? What did you improve? What distro of Linux, Zach, by the way, do you run? I forget. I think I run like Jesse, like Debian Jesse. It's like the oldest. I'm too lazy to update my Linux. I just don't want all my repos to stop working. Oh, okay. Basically, instead of going directly from grade 12 to university, taking an extra and then going. Oh, I see. No, you're not a failure, Ollie. Not at all. Not at all. All right. Little break here. Little break. I always have a big thing I like to harp on is that I think the reason you think you're a failure is you're comparing yourself to others, which is always a bad thing. Don't do that. Because everybody's path is unique. Everyone's path is different. And I like to say, you know, it's not about always going straight. You know, sometimes you go to the left, sometimes you go to the right. You know, we take little detours and side quests. It's about always just going forward. So as long as you're going forward, you're great. You're not a failure. When you start going backwards, that's when we start going into failure territory. Yeah. So don't feel like a failure. Yeah. Also, like, taking a year off in between high school and college could be really nice to, like, recharge and stuff. I never did it because I knew once I did it, I would realize that I like the real world better. I'm like, what am I doing going to school more? Yeah, you're welcome, Molly. Yeah. Yeah, you're not a failure, dude. Failure would be, like, never going to university. Not that you have to go to university to not be a failure, but you know what I mean. You're at least, like, pointing yourself in the right direction. That's what's important. Okay, Y direction, FN1 minus FG1. That has to be equal to 0.
Oh, yeah.
Cool. And then, whoa. I made a mistake. Made a mistake. I forgot about this one. Sorry. Minus F12. Which we already said F12 is the same as FN2. So let's just say this is FN2. Okay. Okay, so then the sum of the forces in the Y direction is just going to be, and this is all equal to 0, right? This is going to be FN2 minus FG2. Allie, what are you going to go study in university? Where are you going to go study? This also is equal to 0. Okay, cool. So this tells me right away, this is beautiful right here, right? This just tells me FN2 is equal to FG2, which is just MG. So this is M2G, which is equal to, what was M2? M2 is 1, right? Oh, so this is just equal to G. Great. Love that. Or we can, yeah, we'll just put G. Just G. Hitman says, I got my grade 12 chem exam tomorrow. Last minute pointers. Is it all of chemistry or what? What specifically in chemistry do you have to do? It was like a final exam? Okay, so we got FN2. I also know what FG1 is, right? So that tells me right away here. So FN1 is equal to FG1 plus FN2. So that's just going to equal to M1G plus G from here, right? Oh, it's all the units. Oh, wow.
Oh shit, not good.
That's a lot. All Canadian kids have exam this week and next week? That's so weird. Why not have exams right before Christmas? I don't know. Maybe that'll all change when Canada becomes the 51st state.
Disqualified.
I can't anymore, dude. We live in like clown land these days. Let's go Canada. Yeah, it's very interesting that you guys end the semester after Christmas. To me, like, Christmas would be too much of a disruption. That's a ban on Dr. Gold.
You're not that guy, bro. Trust me. You're not that guy.
I'm not condoning it. I just think it's funny. We don't want to be part of Trump's plan. Yeah, I know, dude. No one wants to be a part of Trump's plan, dude. The dude's crazy. We're kind of just like sitting watching Grandpa like drunk at the wheel and like waiting for someone to take the keys. Apparently Congress won't do it though, so I don't know. What can you do? I just teach math and science. Oh yeah. Dude, the Greenland stuff is nuts. None of it makes any sense. Okay, let's see. I think we can solve this now, right? No, I think we're good. Yeah, let's get this shit, right? Yeah, because watch this. So now, this is really cool. I'm going to take this equation. Because I already have FN1 now, which is great. Yeah, well, I mean, I don't know why people are surprised. It was the same thing during his first term. The dude just loves the news. Honestly, I kind of missed Joe because we didn't talk about him all the time. He just kind of just chilled up there and just ate his ice cream and shit. But I will say, Trump loves to be, he's a narcissist. He loves to be in the news. So he keeps doing like ridiculous shit to get in the news. It's annoying. But I understand it. I get it. I get it. He's the king of like, there's no such thing as bad press. He is funny. Yeah, he's very funny as a president until it's not. I will say, yeah, no, he is very funny. Was this 0.3? Okay. And then FN2 was G times 0.3, right? And then, oh, look at this. We got two of them actually. Look at that shit. Really? How did that work out? I see. Oh, this is cool actually. So wait a minute. Friction hurts the motion of this one, but it also hurts the motion of this one. Oh, that's cool. This is actually really, really dope. This is actually a very unique case. Do you see how minus FN2 mu s minus FN2 mu s is happening? That's only because of what the rope does. Usually the friction of like this on this and the friction of this on this, they usually fight each other. But because friction is what stops this thing from like moving too much to the left, which is in the negative direction, friction from this also stops this thing from moving too far to the right, which means it acts to the left, which is negative. Peggy says we don't find him funny. Yeah, no, I saw something about how like Canada is now preparing for a southern invasion. Stop. No way. I guess crazier things have happened though. Yeah, the effective friction gets doubled. It's pretty cool. Okay, and then I'm going to add these. So then that's going to be equal to M1 plus M2A. Beautiful. And then this we know is just equal to 3, right? Okay, cool. So we got a bunch of stuff here, right? So I have minus 3, minus 1, minus 1. So that's 20 newtons minus 5G times 0.3 is equal to 3A. So then, whatever, you can just divide by 3. So what is this? 20 minus, I'm going to call G 10. Don't get mad at me. So times 0.3. And then this is all over 3. So what is that? 20 minus 16.66666666. So it's 3.3 repeating over 3. So 1.1 repeating. G equals 10, pi equals 3.
You're not that guy, pal. Trust me. You're not that guy.
Right? Yeah, E equals 3 too. Yeah, exactly. Okay. So this is 1.1111 repeating. Which I think is 11 tenths, right? Is that right? Actually, sorry. 3.333 repeating. Yeah, wait, is 10 thirds, right? 10 thirds over 3? Oh. Wait a minute. Wait. That didn't make any sense. Wait, sorry. Wait, it does. 10 thirds over 3, which should just be equal to 10? I don't believe this. What am I doing? Oh, no, it's 10 ninths. Dude, what am I doing? Oh, my God. 10 ninths. Thank you. You got 1.67. Uh-oh.
Disqualified.
I did something wrong then. Let me think. -3, right? -1 is -5. I don't think I did my math wrong here, did I? Oh. Sorry. Yeah. I don't know why I thought this was. No, this is so wrong. Sorry. It's getting to that point. I'm getting a little tired. Sorry. This is 20 minus 15 over 3, which is equal to 5 over 3, which, yes, is equal to. Thank you, Hitman. Yes. 1.6. I'm going to do it for the kids. 1.67. There you go. There you go. Good job. Cool. Nice question there, Gladiator. It was fun. All right. We're going to go put that in our Discord. Such a tidy and neat solution? Yeah. Well, the nice thing is you get access to that tiny and neat solution right here. Did I download it for you? Nice. There you go. G equals 10. That was clutch for the 6-7. The kids rejoice. Gotta give it to him. Nice. Good job, Gladiator. All right, let's see. What's next? Jamie. Ooh, some inequalities. These are fun. Okay. This inequalities. Oh, and then this is the graph of it. Oh, beautiful. Okay. So whenever you're, well, first of all, wait a minute. Yeah. Some key things here you gotta be careful with. Why this is like not immediately right. So first of all, this is just a less than, not a less than or equal to. So technically, Jamie, you need to put dashed lines here. These gotta be dashed. Well, I think we're shading it is what we want to do. And they want you to shade it. So yeah, the question is, do you shade this part, all right, or do you shade all this part? Because this is the graph of it being equal to, and they want it greater than. So greater than, my assumption, right, is that we're just gonna graph above it. But if you really want to check, you can just pick a point that's in one of the regions and see whether this makes sense. So if I pick the point 0, 0 is a great point to pick out, right? Oh, they already did that for us, sorry. They want to say, wait. This is greater than 0. Oh. Oh, I see. Uh-huh. Okay, oh, I take this back. They want the x values for which this is true. So this right here is y. Yeah, this is kind of weird. I thought this was equal to y. That's what I thought at first. Okay. This is y, and they're saying y is greater than 0. Right? Isn't that what they're saying? And there's 2 points. Yeah. It's from -6 to -3, right? Yeah. That does make it confusing. Okay, sure. Okay, you're right. I see what you're saying. No, you're totally cool. So, yeah. Well, I like to say, like, what, because that's what we have here. We have y equals this, right? Y equals -1/2 x squared minus 4x minus 6. And then we're asking where that is greater than 0. Right, so looking at the graph here, the only places that's greater than 0 is here. Which, yes, is going to be from -6, but this is an open circle. And then all the way to what looks like -2, no? Yeah, -2. We could have also solved this. So, an easy way to solve this, multiply both sides by 2. So you would get, so you have -1/2. Oh, the further you get into math? Okay, Oak Spirit, I get it. We can call it f of x. They just called it y, because I guess this is probably like high school math. But, yeah, I would multiply both sides by -2 here, right? So that would give me x squared plus 8x plus 12. And then because we multiply by a negative, this needs to switch signs. And then this is super simple to solve, right? Because this is 2 and 6. So you get x plus 2, x plus 6. Oh, you do? Wow. Algorithm knows exactly what you need. Yeah, I mean, you can factor out -1/2. It's the same thing as multiplying by -2. This is less than 0, right? So then the solutions where the boundary points you have to check is like x equals -2 and x equals 6. So this is sometimes where like we draw like a number line. Sorry, -6, not +6. So whatever, we can call this like 0. We know this is open. That's going to be -2. Factoring the -1/2 won't change the sign. If you want to get rid of it, I just didn't want to see it. You're right, it wouldn't. But then you would have like a -1/2 here is what you would have. Right? So this is -6. So then what you have to do is you have to check the regions, right? So you got to check here, you got to check here, and you got to check here. So plugging in 0, you get 0 plus 2, which is 2, times 0 plus 6, which is 6. That's 12. Is 12 less than 0? No. It's not. So this region is not good. You try something less than -6. Try like -7. -7. So that would become -5. This would become -1. -5 times -1 is +5. 5 is still not less than 0. No. So this doesn't work. So then the only thing that really works is like in between. Which, yeah. I don't know, -3, right? This is -3 and this is -3. This becomes -1. This becomes 3. -1 times 3 is -3, and -3 is less than 0. So, yeah. That's another way to look at it. So this works. And then, yeah, you could say that this is on the boundary -6, comma -2. You can also look at the graph. Okay. Now here they're telling us to solve this by graphing. So this looks like y is equal to x squared, except it's to the left. Sorry, to the right. Right 5, up 5. And then it's going to be like stretched a little bit. It's like stretched. So right away, or sorry, down 5, not up 5. I don't know what I'm saying. Oh no. Sorry, down 5. right? So minus sign on horizontal transforms is opposite, right? Minus is right, positive is left. But on vertical transforms, up is positive, down is negative. Oscar says, what's a deviation in statistics? Like a standard deviation? It's like how much like variety there is and stuff, I guess. Okay, right 5, left down 5. Okay, and that's gonna be an open circle. Yeah, the minus 1/2 did invert it, yeah. I think what Hitman was saying though is that what we could have done is I could have factored out the negative 1/2 like this and said x squared plus 8x plus 12, and then this would still be greater than 0, and then you could have solved for this, so you would have gotten negative 1/2 x plus 2 x plus 6 is greater than 0. And then yes, technically you haven't flipped the sign, but then you have to always account for this negative when you're testing the points. Tensor question answered. Okay, cool. I'm going to go check that out right after this one, Hamiltonian. Thank you, dude. I appreciate that. Okay. So we know this is this. We also know it's facing up. Not fucking up, sorry. Facing up. Because it looks like this. Because this is positive. So you could go find some points. I don't know. You want to plug in 0, 0? It's kind of like, it's a messy, actually really messy one. Actually, you really don't want that one. Oh man, this is just like not nice. Step method? What's the step method? Do I just like step 1 point over? Is that the step method? Right? Yeah. So what? If I plug in 6 minus 5 is 1. And I get 4 minus 5 was negative 1. Okay, so like this is technically a point, yeah. And then this will also be a point. I agree. This is a very narrow and steep thing. Yeah, just do something like that. It should that times 4 just like fucks with things. Okay, something like that. And then if it's if it's greater than ay plus v x over k plus d using x squared. Yeah, exactly. No, I get you. Yeah, all the y values go up by a factor 4, and then they're also shifted down by 5. So going 1 away, right, should really get you 1 up, but in this case it gets you 4 up, but then you're already 5 down, so that's why it's negative 1. I see what you're saying. Yeah, so if you went 2 over, you should go 4 up on a standard x squared. But then, because of the extra 4, you're going to go up 16. And then minus 5 is going to put you at 11. Yeah. Right, now they want us to shade it. Yeah. So this is where you're either going to shade this or you're going to shade this. It's definitely this. But if you wanted to check, you can always check a point. For instance, 0, 0, and see what happens. I just know this is how they teach it in school. You just check 0, 0. So you get 0 is greater than 4, 0 minus 5 squared minus 5. And so that gets you 0 is greater than 100 minus 5 is equal to 95. Is 0 greater than 95? There is not. So, yeah. So this is the answer. I don't get the shading part. What's the point of the shading? Well, they want to know what are all the values of y that are greater than this function, depending on where x is, right? So, for instance, when x is equal to 5, right, you get, so when x equals 5, you get y is greater than negative 5. And so that's why here on the graph, right, at x equals 5, you're allowed all y values that are greater than negative 5. But when y equals 6, sorry, when x equals 6, for instance, right, now you're allowed all y values that are greater than negative 1. And then so forth and so forth. This inequality changes based on what the x value is. So the shading just shows you, like, dependent on what x is, what are my allowed values of y. Yeah. So yeah, it's like this, and it's like this, and then like something like that. Heart. Thank you for the heart, Opal. Cool. All right, nice. Great question. Yes. Oh, yeah. You're right. Sorry. Yeah, that's just me being lazy. You're right. Sorry. That's me being lazy. Sorry. I just didn't want to mess this up. Okay, there we go. Thank you, Psycode. No, you're right. Because otherwise, a student could see that and be like, oh, is it just when y is greater than 0? And it's like, no. Huh? No, it's not true. No, you're super right. You're super right. Okay, that was Jamie. Okay. All right, Jamie, we're going to put your question in the Discord. I want to see what Tensi came up with for the tensor one. Ooh. Oh, okay. Well, this is fascinating because there's already 2 pages of things going on. Let's see. Thank you, Bob, by the way. I'm going to give you... Appreciate you. Let's give you some rolls. I'm going to give you some... I don't know, this is kind of like physics. There you go. Yeah, now you have increased rolls. Okay. Phi is a scalar field. So, and then this... Let me see what the original question was. This one. Show that the second derivative of the potential, of the field, which is usually potential, right? With dxj dxk, which is tensor jk, is a second rank tensor. Okay. So you said, I assume this is in Euclidean space. Okay. Then the field is equal to the other field under a change of coordinates. Okay, that's cool. That makes sense. So, yeah, the value of the field should not change based on, like, where we're measuring it from. Assuming that xi and xi squiggle are both sets of Cartesian coordinates for a Euclidean manifold. This is a big assumption. Under the coordinate transformation, x going to xi squiggle is the same thing over L. And these are coefficients, I guess, right? Or these are or is this like a transformation matrix here, this AI? And then this is a constant matrix because we were transforming between Cartesian coordinate systems. We can invert this. Okay. Which is also a constant matrix, okay. And then using the chain rule, dx squiggle is dx squiggle ddx. Yes, okay. I don't remember all this. This is from another person in my server who wrote this. Prov, I didn't write this. This is from Hamiltonian Dynamics, the user. Okay, so, and then this you're saying is A inverse. Oh, okay. I think I see where that's coming from. Oh, because with respect to x squiggle, yeah, the x squiggle goes away. Okay. Cool. I like that you wrote this step out. Okay, great. And then the sum over L. Dude, this is always, and this is a Dirac delta, I guess is what's happening here, right? Dirac delta LJ. So this is only non-zero if L is equal to J. Wow. Okay. So then we can figure out how the second derivative transforms. No, you're totally okay. Some context to... I don't understand this either, Hitman, so you're totally okay. Tensors are, like... They're like vectors on steroids. They're like vectors, but in many different dimensions at once. This stuff really gets used in quantum mechanics. Or like quantum gravity stuff. So again, if you're in high school, you're never going to use this. But if you get to college and you end up going the theorist route in physics, you will deal a lot with tensors. I barely touched them because I did experimental physics for my PhD. But I think I can kind of understand what's going on here. I see, because yeah, so this part right here, when you say dxl, dxj, this thing is only non-zero if L is equal to J. If you're only looking at the same index, right? Otherwise, you'd be doing like the derivative of Y with respect to X, and like they don't depend on each other. Like yeah, okay. I think I see this. dxi dxj. Yeah, that's cool, Hamiltonian dynamics. I get it. Yeah. Because from this definition, I see. And you're okay. X squiggle is AIXL, but then XI is A inverse X squiggle. The inverse matrix. Okay, I think I get that. Okay, so then you want to take the second derivative, which we already showed, right? Yeah. If you want to take the first derivative, you have to do AI inverse ddxi over ij. Okay, so this is the first derivative. And then this is the second derivative part we came up with, which now you have a new index. This is A inverse nk. Because these are two separate indices, the i's and the n's. Okay. Now remember, A inverse is a constant. Okay. So you can pull it out. Right. Okay. And then these. Right. This is that came from this, I think. Right. When I have the partials here, I got aij. Oh, you're transforming them back, actually, right? You're transforming these back to this form. And then this is the transformation behavior of a rank 2 tensor. I didn't know this. Okay. This only works because X and X squiggle are Cartesian coordinate systems. In curved space or curvilinear is not a tensor. Okay, cool. So I guess this is the definition of a rank 2 tensor. And I didn't know that. But I can extract some nuggets from this. Like, I can understand some of this. That's cool. Thank you, Hamiltonian Dynamics. Really appreciate it. Or as you go as Bob in our Discord. I gave you some fancy roles, Bob, because you seem smart. So you are now a math god, a physics god, and an actual educator. Congrats. A tensor is something that transforms like a tensor? You can't use the word in the definition. Yeah. I know, physics is the worst with that. Alright, let's see. What else do we have on our queue of questions? Alright, Jacob. Jacob, did I just do one of your questions, Jacob? No, I did Jamie's. And then Amy. Amy, are you still here? You asked a question too. Bro, school's low-key easier than working at a startup? Yeah, of course it is. What? School has a very, like, well-defined set of rules and, like, I don't know, milestones and ways to have success. Startup, you have to, like, kind of figure it out on your own. Quite difficult, actually. Oh, Waterloo, congrats. It's a great school. Okay, what is the tangent line? I don't know, like instantaneous rate of change. A tangent line is tangent to a curve.
Surprise, motherfucker.
A tensor is something that behaves like a tensor. You're working 996? What does 996 mean? 9 hours of school, 9 hours of startup, 6 hours of sleep. When do you eat? What is the value of the slope of a V versus T graph for a falling object? Oh, 9 a.m. to 9 p.m. 6 days a week. I mean, that seems like a lot. Slope there is negative 9.8 because that's gravity. I only work right now. Okay. I mean, make sure you save some time for like being a person. You know, I'm all for like, you know, pouring your heart and soul and time into things, but especially in like your 20s, make sure you have like some time to like develop as a person. It's important. It'll help you out a lot. Like take some time off and go travel. See the world. See other viewpoints. It'll help you out with your startup stuff too, actually. You get fresh ideas. Because that's gravity. Fine. You want to say like because delta V over delta T is equal to A. Acceleration. Yeah. If wind resistance was included in the previous question, would the slope get bigger or smaller? Ooh. It would get well. Technically, the slope gets bigger because it becomes less negative, right? So less negative. That's a trick question. Does the slope get bigger? I would love to repeat high school with my current knowledge. Yeah, right. You would just be doing it on God mode. I think about that nowadays. If I were to go back, 15 years ago and just like start doing high school and college again, I would just like cruise through shit. But you don't want to do that. You've already spent all that time to get to this point. You don't want to have to like no repeat experiences. So I don't know. This is technically smaller. I mean, the magnitude gets magnitude. Or less negative is. What's up, clickbait? I don't know. Whatever. I'm gonna say greater. Greater. Describe the Apollo 15 experiment involving the hammer and feather. Explaining why it doesn't work on Earth. Yes, this was a cool one. Things fall at the same rate, independent of mass. Explain why it doesn't work on Earth. On Earth, you have wind resistance. Which does depend on mass and also like the shape of an object. Because the Earth had Isaac Newton. Yeah. What's the acceleration here? Ooh, okay. So looking at this, that's you can say like delta V over delta T. So that's 25 over 2, so around 12.5 meters per second squared. 15 minutes left. You want to do some perturbation theory? I don't know if I could do it in 15 minutes. Perturbation theory is cool, though. For the hydrogen atom, at least. It's cool to see how, like, the delta, right, just, like, propagates through things. All right, cool. Sketch D versus T for a stone that was dropped. So D versus T would look something like this. And then V versus T. looks something like that. And then thrown upwards. Ooh, okay. So in this case, D versus T looks like this. But then velocity starts positive, eventually goes to 0. So this is at the max height. And then it goes negative. Okay, cool. Let me know, Jacob, if you wanted me to explain any of those other parts a little bit more. I'm just trying to like make sure I get through everyone's questions before we run out of time. But cool. Physics.
Good job.
Physics. Jacob. Jacob. Just scratching the surface, but it is neat. 3 lectures in, so square roll corrections. Yeah, the corrections. Yeah, you do a bunch of like corrections to what the original Schrodinger solution thing is. All right, let me see. Who have I not helped yet? Who's asked a question? Trecto or Oak Spirit? Oak Spirit, have I? Dude, what? Excuse me. What the fuck is this? Oak Spirit, what the fuck? I mean, this is cool, but I have no clue what this is. Oh, you're okay, dude. Let me see. Oh, discrete time system. Wow. Oh, was the other thing a weight scale? Oh, I see what you're saying. Yeah, if someone steps on this. Oh, very cool. It measures the capacitance. Well, this says level is equal to C minus C dry. Pretty cool. What's up, Justin? It's a fluid measuring device. I'm wondering if I can measure the level of fluid between plates like this. Oh. Yeah, I think so. I mean, capacitor, 2 plates, contacts. Oh, I see. You're coming up with like a clever way to measure the depth of the water. Yeah, I don't see why not. As long as you know what the capacitance of the fluid is. So you need to do it for it being full and then for it being dry. And then I assume it's a linear, right? Yeah, it's a linear relationship then. But you need to know what like the low and the high are. You're trying to make it? That's really cool, dude. It's smart. It's a smart idea. Right, because capacitance is dependent on the material in between it, and you assume the fluid has a dielectric constant different than the dielectric constant for vacuum. My only concern would maybe be, like, what's the resolution that you can measure, right, on the voltages, because the difference in the capacitance might be, like, really, really tiny. Yeah, exactly. Yeah, right. Yeah, so the more precision you want to have in this sort of case, you need like infinitely more precision in the voltage, right, that you're measuring. So one way to increase that is, yeah, to increase the area, right? Because more area means that your change in capacitance would be more, but that's only going to be a linear change, right? So then it depends on the precision of whatever circuit, whatever DAC you're using here in order to check it. But check it out. I think it's cool. I think you could use it. Yeah. Let me see. Someone got something nice. Here, let me do Amy's real quick because I know I can do this. The eigenvalue ones, I don't know if I can do in 12 minutes. Where's Amy? Amy, were you in our chat, Amy? More inequalities. Love inequalities. Oh, these are actually kind of weird. I remember these. You have to find like... Yeah, there's gonna be a lot of like signal to noise ratio stuff going on. Now, wait a minute. I think what you're allowed to do... Are you allowed to just, like, multiply this over? So you get 4x minus 3 is greater than or equal to 3x plus 6? Yeah, that's some cool stuff. And then I think you just get... Yeah, and you gotta deal with 2 graphs. Well, there's a restriction, right? X cannot equal negative 2. Right? Because otherwise this blows up. So right away you can just put like a hole at negative 2. But then I think this is okay. I think you can just do algebra, right? Can't you just subtract this and then like move this? So what? This is x minus 9 is greater than or equal to 0. So x is greater than or equal to 9. So then negative 2 isn't even an issue. Right? Bonum. Yeah. So I think you literally just draw a whole, like this at 9, and then you just do it to the right. I think that's all you have to do. We could try graphing it if we wanted to, right? What is this, Desmos? So 4x minus 3 divided by x plus 2, right? And then we want this to be greater than or equal to 9? Or wait. 4x minus 3, x plus 2, greater than or equal to 3. Oh, so that actually works for a lot of points. Right? So that is true on the right side. Right? That's when x is greater than 9. So that one's correct. But notice how I missed all these. Oh, fuck. Yeah. I know the other way to do that. Yeah. Yeah, so I guess this doesn't work this way. But it only gets one of the solutions. So the other way to do this, right, yeah, is to say that 4x minus 3 x plus 2. I think minus 3 is greater than or equal to 0. Is that what you do? Yeah, what's up, Norino?
Yeah.
Raid. Hi, guys. Welcome. Thank you, Arduino. Appreciate the raid. A little late night fun we're having here. My name is Dr. Gold. This is Actual Education. We're a Twitch stream and 501c3 nonprofit, and we help students out with all sorts of math and science homework that they give to our stream here. So if you or anyone you know needs help in, I don't know, we were doing some physics here earlier. Someone was asking physics questions. We had some linear algebra we were doing too. More physics. What was this? This was like kind of some math. But yeah. Feel free. Appreciate the raid. Thank you to Arduino. We still gotta go get beers. We live in like the same area. But awesome, yeah. And if you guys want to learn more, or if you have your own question you want to submit, the website for that is actualofficehours.com. February 1st. Yeah, are you doing dry January as well? It's kind of rough. My friend was asking, hey, how's your dry January going? I'm like, it fucking sucks. It's boring. But yes. Yeah, but yeah. Okay, February 1st. Good. Awesome. We'll do it. We'll celebrate. But this is the website we have if you guys ever want to submit any questions to us. You can also join our Discord. That's where we post all the solutions for everything we do. And anything that's difficult that we want help with, other people in the crowd are always great at donating their expertise. We had that happen today, actually. I didn't know what tensors were. Well, I know what tensors are. I don't know how to work with them. But one student submitted this question asking about showing whether a scalar field is a second-rank tensor. And Bob was really nice. He came up with a solution here and wrote something up that was super dope. So we love to just kind of pool together all the awesome knowledge of you guys, myself, and all our other friends to help out students with math and science questions all across the different streaming platforms. And then, yeah, also on the website, you can click on the streaming schedule, and that shows a calendar of like when we stream. People always ask, like, when are you streaming? And also when all our other friends stream. So, sweet. Okay. Cool. I think we were solving this one. This is like a quick little easy. It should be an easy inequality. I was getting kind of wrecked on it, though.
You done messed up, AA Ron!
What the fuck is this piece of shit?
Because when we solve this the normal way of I just multiply this over on the right side and then solve for x, I got that x was greater than or equal to 9. Which on Desmos, if we were to graph this inequality, this expression, pretty easy to see that, yeah, when x is greater than 9, this function is greater than 3. But you miss out on everything here on the left.
No.
So, I think someone suggested just set it equal to 0. And then maybe check, like, what points where that happens. Because, yeah, I think the other thing you have to check is whenever this, like, blows up and does weird stuff.
No.
So, for instance, I think x equals -2 is what we call like a critical point that we have to look at. And actually, let's look at the graph that we had of that. Where was our graph? Is -2 the case? -2 is the asymptote. How do I show that everything to the left of it is also greater than 3? Oh, I think I see what we do. Once you have a critical point, you have to then check the regions to the left and to the right of that critical point. So, for instance, if I plug in 0 into this, that's checking the region between -2 and 9. This would give me -3 over 2. Is that greater than or equal to 3?
No.
It's not. Right, good. Yeah, Hitman's right, yeah. So then I need to check to the left of -2, which we could check -3, right, for instance. If I check -3, we get -12 minus 3 over -1. And so that gets me 15. Is 15 greater than 3? It is. Okay, cool. So that actually tells me all of this is actually okay. Okay, I think I understand how to do these. This is like pre-calc stuff, but, you know, I don't remember everything. So there we go. Cool. So this is the correct one for this. Agree with that. Oh, so let's use the same strat on this one now. Right away, I know this is something I can factor. So, like, what multiplies to 6 but adds up to -7? That's -1 and -6. Oh, if we wanted to write this, yeah, we should write this, Gladiator. Yeah, let's do that. If you want to write this in interval notation, -∞, comma -2, parentheses, union. Then this is going to be a bracket around the 9, because we include the 9. And then infinity, parentheses. Because nothing can ever equal infinity. Infinity is a constant. Or it's an arbitrary concept. It's the same as like home ownership, like for my generation, right? This is just an abstract thing.
Huh?
That we will never get to. Okay, so -6 and -1 multiplied to +6 add up to -7. So I can now write this as x plus 4. And then this is going to be x minus 1, x minus 6. And then this is less than or equal to 0. Cool. So a couple critical points here already, right? X equals 1, critical.
No.
We don't like that. That's going to do bad things. X equals 6. And then the other one, I guess, yeah, is when this equals 0, because we're just setting it equal to 0. And that's when x is equal to -4. So we got to go plot some things here. So let's put 1 here at 1. Let's put another one out here at 6. And another one here at -4. And then notice we're putting closed circles, because these are all less than or equal to. Okay. So when you have that less than or equal to, you don't put an open circle, you put a closed circle, because it includes that point. So now we have a bunch of regions we can test. We can test here, 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 and here. So let's go with the simplest one, 0. When I plug 0 in, I get 4 over -1, -6. Yeah, you test close ones. You can test actually anything in between. I tend to pick, I tend to pick like 0 just because it's just nice. If it's nice, we play it twice. So 0 gets me, because I'm just checking whether it's positive or negative. So if I have a positive divided by 2 negatives, multiplying by each other, these become positive.
Good job.
And then a positive or positive is positive, but I need it to be less than.
No.
So this does not work.
No.
Can't do that. Cool. All right, so let's pick something in between. Maybe let's try like 3. So 3 plus 4 is 7, so that's a positive. 3 minus 1 is 2, positive. 3 minus 6, negative. Uh-oh. Positive over a positive times a negative is a negative. But then that's less than 0, so, ooh, okay, great. So this is okay. So we're cool here. I'm guessing when x equals 7, we don't have something good, right? Let's check 7. Positive, 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 all positive, but I need it to be less than 0, so this is not gonna work. And then let's just check -5. So -5 would give me a negative on the top, a negative on the bottom, another negative on the bottom. And so then this multiplies together to a positive, and then a negative over a positive is a negative. And so this one's okay. Yeah, nice. Okay, cool. So we got these regions. So this region and this region are okay. So again, if you wanted to write that in terms of interval notation, that's -infinity, comma 4 with a bracket, because it's a solid line. Then we skip all this, and we say union 1 to 6. But in this case, 1 and 6 are included. Nice. There you go. And that's how you do that one. Nice. Good question, Amy. Appreciate it. It was fun for me to like remember how to work with inequalities. We've had everything today. We've had everything from linear algebra to calculus to, yeah, basic inequalities. This will help you for your exam on Friday? Fuck yeah. Good luck on your exam, by the way. All my Canadian friends apparently have exams this week because Canada does final exams after Christmas. That's terrible. I don't know. Like, I feel like in America it's just like it's a mad dash sprint to just get all your exams done by Christmas, and then we just vegetate until like, I don't know, middle end of January, and then it's like, oh, I actually have to start doing shit now. I also have an advanced functions exam on Friday. Okay. Canada wants to be a little different from the US. Yeah. For now.
You're not that guy. Trust me. You're not that guy.
Uh-oh. Okay. All right. I think that's it. We're out of time today. We did 3 hours of streaming today, but appreciate everyone that asked some questions today. Let's close out the stream. We'll go raid someone fun. All right. Thank you everyone for coming to Actual Education office hours today. Appreciate everyone who came by. Thanks for the raid, Arduino, by the way. Thanks for bringing your crowd on by to say hi to us. So again, if you ever have questions about anything math or science, or you have kids who need help with their math and science, or you know friends, or kids with friends, or wait, friends with kids. I feel like I know less friends with kids than kids with friends. Yes, thank you. Please feel free to point them to our Discord, to our Twitch stream. We stream also on YouTube. We stream on TikTok. We stream on all the platforms to help all you guys out as much as we can. So I appreciate getting the word out. And awesome, Fanatic, you're having a breakthrough with your algebra software. I'm hyped for it, dude. You know, let me plug you a little bit to people, because we have an awesome community of people that all do different sorts of things. This is our TikTok, but where is it? Mathematic Fanatic. Mathematic. I'm pretty sure I follow you. There we go. So Mathematic Fanatic, for instance, has been developing like Python code to, I want to say this is to use, Manum is a cool programming language to display math things. Was someone telling me that 3 blue, 1 brown or whatever, did he develop this language? But anyways, you can tell his code here to solve for a variable and it'll do the appropriate like order of operations to animate that, which I think is really cool. Fanatic, please keep doing this. I would love some sort of code like this because most of my TikTok tutorials I make, a lot of the stuff that sucks is having to do all the animations of like how all the numbers move around. I'm having to be like, well, I don't know, we could skip ahead or something, but yeah, stuff like this. I'm like, oh, well, you know, this goes this and this goes this and this and this. And I would love if I could just like tell Python to just write some code and just do it. Because otherwise you have to like split things and yeah, it's kind of annoying. Did you hear about the new chip they developed that can solve something that would take a normal algorithm about 26 septillion years? It's probably something with quantum, probably a quantum computer or something. It's in Miami. Don't trust anything you hear that's in Miami, dude. Wait, what? I've heard a lot of things that are in Miami that aren't true. Yes. Oh, okay. Yeah, 3 blue, 1 brown wrote Manum. That's super cool. All right, let's go raid someone. So I love to go support other people who are streaming math and science stuff. Who's up at this hour of the night doing something intelligent? Physics and depression. Hell yeah, we're gonna get him before he stops. Okay. Physics and depression is a cool person. He does a lot of like physics help, and he actually just like works through physics textbooks. He used to be a physics professor as well, so we love him. He's great. Okay. That being said, this is the last stream of the week because I have to fly out tomorrow to go see my family in Seattle. But next week we'll be back streaming 4 times a week, so make sure like, subscribe, follow, all that fun stuff. Join our Discord, and we'll keep the fun going. Okay, cool. All right, we're gonna go raid physics and depression. So enjoy the rest of your Tuesday. Have a wonderful, fantastic week. We will see you on Monday. Peace.
You know, I think that sort of speaks for itself. I think that when people of the time hate someone, then that really kind of closes the book on whether we should be looking at them in reverence today. With regards to George Washington, no, and I don't think that anyone who